Okay, so here's part 2 of lesson 7.3. We are going to be proving triangles similar. We started this a little bit yesterday, and we're going to continue to apply those angle, side, side similarity statements. So remember yesterday we went through the angle, similarity, side, side similarity, side, side similarity. So now we're just going to continue to work on that. So if I'm looking at these two triangles, I'm going to make them, to see if they're similar, I'm going to have to figure out what x is. Well, I'm going to look at these two triangles, and I notice that JK is similar because I have this one tick on the angle and the two ticks here. I'm going to find the side that has one tick and two ticks. So it's going to be this side. So in order to figure that out, we're going to go from the small triangle to the big triangle, left to right. And then I'm going to look and see the other side, the one that has one tick on the angle, one tick on the angle. So those two are similar. So again, I'm going to go from the small triangle to the big triangle, or left to right, set them equal, and cross multiply. So 6 times 12 is 72, equals 8x. So divide by 8, x equals 9. Wait. Yeah, x equals 9. So then we throw that back in here. And we say, okay, these are congruent. How are they congruent? Because we have congruent. How are they similar? They're similar because they have a side, an angle in between, and a side. So these are going to be side, angle, side. And now I have to name the triangles, make sure that I get it right. So I'm going to start with the two ticks, one tick and then no ticks. K, J, L, two ticks, E, one tick, C, D. Now to this one, we have 3 sides on that triangle ACB, and we have only 2 sides on VDE. So now I'm looking at this trying to figure out which sides are congruent. So I'm thinking that which sides are similar. I said congruent again, sorry guys. I'm thinking that AC is going to be similar to DE. And then I'm going to say that I believe BC is going to be similar to BD. So, in order to figure out x, I'm going to set this similar to this. So I'm going to go from this left to the right, 10 over x. And then I'm going to see this side similar to this side. So I'm going to say 16 to 24. And so those equal. Cross multiply. 240 equals 16x. So x equals 15. So if I put that back in this triangle, now we say these triangles are similar. X is 15. Okay, so triangles are similar. Well, why are they similar? Well, what we need to do is we set up the ratios to see if they reduce to the right fraction. So 10 is to 15 equals the middle one is 12 is to 18, and the big one is 16 is to 24. You see where those numbers came from? Please look at your picture and figure that out. Okay, so now I'm going to reduce. Are these the same? So if I reduce it by 5, I get 2/3. Does that equal? If I reduce by 6, I get 2/3. And if I reduce by 8, I get 2/3. So this is true. That means that they are congruent, but similar by side, side, side. Side, side, side similarity. So now I have to name the triangles. So I'm going to start with C to A, C, A, B. That means I'm going to start with E to D, E, D, D. All right. Again, we've got to find X. Now this is going to be a little bit trickier, so let's figure out where we're looking so that we can figure out which sides to use. As I'm looking at this picture, I'm noticing that on the larger triangle, we have two sides that are by the right angle. So I've got this side, and then I've got this side. So it looks to me like we are going to have 8 and 3 and 15 and X. Again, I'm moving left to right. It really doesn't matter which way you do it, but I'm going to move from the large triangle to the small triangle this time from left to right. So I'm going to go 8 is to 3, as 15 is to X, set them equal, do my cross multiply. 8X equals 45. Okay. So divide that by 8. This is weird. I end up with X equaling approximately 5.6. Okay. Well, I've got a decimal, so now what? All right, well, we're going to see if these two fractions are reducible. So we've got 8 over 3. Does that equal, question mark, 15 over 5.6? Well, in order to figure that out, I need to scale that by 10 so that I don't have this funky 56 here. So I'm going to say 150 scaled over by 556. Now can I reduce that to be 8 over 3? Well, I know that 2 goes into 150, so that's 75 over 56 divided by 2. 28. Well, I can divide by 5, but that's not going to reduce it. So I'm thinking that this is not similar, but I think we need to go over this one in class tomorrow because I'm not 100% sure. So I said 5.6 is X, but I don't think it's similar. So the answer is no. We'll see if that's right. I'm not sure. All right, this one looks better. Believe it or not, it looks better. What we did here is we have a small triangle right here, and we have this triangle And we took the small triangle and put it right here. And we took the big triangle and put it right here. All right. So we have to set up a proportion to figure out what x is. The first thing that we have to do. So I'm going to say x and x plus 1 are going to be similar. So x plus 1. And I'm going to say 8 and 10. 8 and 10 equals, so now when we do this, it's just a lot of algebra. We got 10x equals 8 times x plus 1. Remember your parentheses, remember to distribute. So 10x equals 8x plus 8. So I'm going to subtract 8x from both sides. So that's 2x equals 8, x equals 4. So now I can figure out if these are similar by plugging x into the problem. This whole side is going to be 5, and this is 4. Okay, so now we can see if those triangles are similar. So I'm going to say 4 is to 5. Does that equal to 8 over 10? Well, if it's 4 over 5, and I reduce by 2, I get 4 over 5. So yes, they are similar. Now we have to figure out why. Well, we have an angle here, so it could be side angle side, because that is the same in both triangles. It's the same angle. So we have side angle side, and we have to name our triangles. So WVS and TVZ. Okay, so now we're looking to see these similar triangles, and then you're going to see a lot of trees and mirrors and people looking into mirrors, into trees. What I'd like you to do is draw a little tree from TR. Draw a tree right there where it says TR, because that will tell me that you actually listened to the video. So now we are looking at setting a ratio equal to each other. And for this purposes, I'm going to use TR. I'm going to make an X here, because that's going to help us set up the ratio. So I'm going to say 5 is to X. Do you see why? Because those are the two vertical ones. And then I'm going to set 3 over 24. And do my cross multiplying. So I end up with 3x equals 120. So we divide by 3, divide by 3, x equals 40. So this tree is 40 feet tall. Don't forget the label, 40 feet, because it asks how tall is the tree. Okay, now we've got a cactus. Again, it's the same concept. We're just setting this ratio equal so we can figure out how tall that cactus is. So I'm going to say 6 and x, 6 and x, 4 and 9. Set them equal and do the cross multiplying. So we get 54 equals 4x, and divide by 4. I don't remember what that is either. Now, what label are they using? They're using feet. Okay, again, we're going to see buildings and people. So we have two triangles that we pulled out of this. And now we're going to take our measurements and put them on the two triangles on the right-hand side. All right. So, they say 5'6" is the same as 5.5 feet. You're going to keep that in mind too. So, this small triangle is right over here. And the person is 5.5. And the distance on the bottom is 14. Now we've got the big triangle. The height is x. And now the bottom is this distance plus this distance. So it's going to be 328 plus 14, which equals 342. Okay, so now we just have to set that up. So it's going to be 5.5 and x, 5.5 and x, and then I'm going to do the small triangle to the large triangle, 14 over 342, multiplied by 5.5, 1,881 equals 14x, divide by 14, equals 134.4. And what is that? That's going to be feet. So the answer is 134.4 feet. Remember, you're going to round to the nearest 10. Okay, here's another common one that you'll see is we've got to figure out how far it is across that river. I don't want to go out there with a tape measure in the river because, you know, it's like getting wet. So we're going to make two similar triangles and then figure out how far it is across the river. So we have the two triangles drawn to the right. We've got the small one and then the large one. So for the small one, let's figure out the measurements. We've got x and we've got 75 because we don't know how far it is across that river. And we do know that now the green one, I know that this is 100, that's easy enough. But now I have, x plus 20 to get that whole side. So it's going to be algebra. Okay, so let's set those two sides equal. Let's set the x's. And then 75, 100. Okay, so I end up with 100x equals 75 times x plus 20. All right, so 100x, distribute, 75x plus, I don't know that off the top of my head, so I have to figure it out. 75 times 20, 1,500. Okay, so now we're going to subtract 75x. We end up with 25x equals 1,500. So x equals 60. We scroll up. X is 60 meters. So your answer is 60 meters. So that's it, and be ready to work
working class tomorrow. Make sure you have questions, and we're gonna check that one that I didn't know. Thanks a lot.
Bye now, have a good night.